Beneath the streets, above the skyline, New York is reshaping itself at every level, and what's rising now may be the boldest wave yet. Glass towers replacing icons, tunnels boring beneath rivers, platforms floating above live rail lines. This isn't just construction, it's reinvention at scale. New York has always been a city of extremes, height, density, ambition, but in 2025, its biggest feats aren't just visible. Some are hidden deep underground or tucked between rail lines and rooftops. This is more than development. It's a balancing act between legacy and scale, and what's underway now is testing the limits of what a city can handle. And no project tested that balance more than the one that began with demolition and rose back higher. It's the tallest intentionally demolished building in history, and what's taking its place might be one of the most precisely executed skyscrapers ever attempted. 270 Park Avenue. The new J.P. Morgan Chase headquarters replaces the mid-century Union Carbide building, disassembled floor by floor in the heart of Midtown. Demolition required vibration sensors, internal bracing, and meticulous sequencing to avoid disturbing nearby towers. And Grand Central Terminal, no explosives, no shortcuts. Crews then drilled deep into Manhattan's bedrock, poured a concrete mat foundation, and began erecting a hybrid concrete and steel superstructure. The new tower will rise over 1,200 feet, engineered to LEED Platinum standards with prefabricated curtain wall panels, centralized mechanical cores, and a braced frame for lateral stability. This isn't just another office building. It's a zero-tolerance machine built to outlast the century and the competition. At its peak, more than 2,500 construction workers were active on site. The logistics behind steel delivery, crane positioning, and modular assembly were a mega project in their own right. And with rising energy standards, the building's systems were designed to operate 40% more efficiently than comparable towers. Even the curtain wall itself functions as an energy-optimized membrane, reducing solar heat gain while still delivering full natural light. Inside, underfloor air distribution systems and dynamic daylight controls contribute to both comfort and performance. But while this project soars upward, another is being carved beneath one of America's most iconic rivers. To the west, the Gateway program is tunneling toward the future, beneath the Hudson River. The goal: build 2 new rail tunnels to relieve and eventually replace the century-old North River tunnels, vital arteries used by over 200,000 riders daily. The old tunnels were battered by Hurricane Sandy and show increasing signs of saltwater corrosion, cracking, and instability. Using tunnel boring machines, engineers are digging 2.5 miles under soft silt and dense bedrock. The alignment must thread between building foundations, subway lines, and buried utility corridors, with real-time geospatial mapping to detect even millimeter shifts. Each tunnel will feature precast concrete lining, fire suppression, advanced ventilation, and electrical systems ready for high-speed rail integration. When complete, the tunnels will not only double capacity, they'll also allow phased rehabilitation of the originals without service disruption. For the Northeast Corridor, it's a lifeline. For New York, it's buried momentum. And above ground, the work doesn't stop. Ventilation towers, access shafts, and support facilities are being constructed in tandem, integrated into city blocks and designed with architectural sensitivity to the surrounding neighborhoods. This project isn't just a tunnel, it's a safeguard for the entire regional economy. It's also a political statement, with federal, state, and bi-state coordination finally aligning after years of delay. And in a city that runs on rail, it may be the most important thing we never see. But transportation isn't just about rails. For millions, it begins and ends with a bus and a terminal past its prime. New York's Port Authority bus terminal is the busiest in the Western Hemisphere, but also one of its most outdated. Serving over 200,000 passengers daily, the terminal has long exceeded its capacity. The current replacement effort is one of the most complex transit overhauls in US history. Why? Because it has to remain operational throughout. Temporary bus staging areas are being built nearby using modular steel framing and precast slabs. Once operational, the existing terminal will be demolished in phases. Excavation will go multiple levels deep, not just for staging bays, but for new stormwater detention systems, MEP infrastructure, and pedestrian concourses. The new terminal will include modern ventilation systems, lighting, regenerative elevators, and significantly expanded boarding areas. Its foundation must interface with nearby rail tunnels, requiring extreme precision during pile driving and load transfer. All of this must happen while buses continue to arrive every day. From terminal congestion to aerial engineering, some of New York's most ambitious projects never even touch the ground. Right next door, the Manhattan West Megaproject is redefining what it means to build above constraints. This multi-tower complex floats over 30 active train lines, with no service interruptions. The secret? More than 300 caissons drilled between tracks into bedrock, supporting a steel and concrete platform. Crews built it at night, using custom rigs and gantry cranes to set massive transfer girders. Once the deck was formed, towers began to rise. Today, One Manhattan West, a 67-story tower, stands as the flagship of the site. Built with a composite steel frame and concrete core, it's engineered for wind, vibration, and vertical efficiency. Below, public plazas and retail corridors connect the site to Hudson Yards. Above, the skyline reflects a feat of structural choreography. This isn't just construction, it's a lesson in spatial invention, turning what was once unbuildable into one of the most valuable parcels in Manhattan. And across the river, a different kind of innovation is reshaping the city, one built on tech, climate resilience, and modular speed. On Roosevelt Island, the Cornell Tech campus is quietly redefining what an urban institution can be. What was once a hospital site is now a net-zero research hub built for climate adaptation. Its centerpiece, the Bloomberg Center, runs on geothermal systems, solar panels, and airtight thermal performance. The Tata Innovation Center uses hybrid framing for flexible research floors and is wrapped in glass, designed for daylight control and ventilation. And the House, Cornell's residential tower, is one of the tallest passive house structures in the world, assembled modularly with triple-pane windows, airtight seals, and ultra-low energy use. Flood protection, smart utilities, and green roofs wrap the campus, designed not just for 2025, but for the next 100-year storm. Because in New York, even resilience is built from ambition. In New York, space is tight, time is limited, and the stakes are always high. But somehow, the city keeps building. Upward, inward, forward. These aren't just projects. They're experiments in scale, proof that even the most complex city on Earth can still surprise us. Which one impressed you most? Let us know below. And subscribe for more stories of structures in motion and the people building what comes next.